Hello everyone, my name is Hoang-Giang, from Computer Game and Intelligence Lab National Yangming Jiao Tong University, Taiwan. I'm glad to present our work, Learning Sim to Real Dense Object Descriptors for Robotic Manipulation. Out descriptors solve two critical issues in robotic learning tasks. The first is understanding the object through appropriate object representation. The second is the ability to constantly represent simulated and real image data at the pixel level. Our SRDON with sim-to-real object representation consistency can be used as a building block for various sim-to-real manipulation tasks. Our experiments show that pre-trained SRDON can significantly improve performance on various robotic tasks with zero real-world training, even in unseen object and visual environments. Florence introduced dense object nets, which use pixel-wise correspondence to learn the dense visual descriptor. The objective is to minimize the representation of match points and keep a distance m between non-match points. The result of dense object nets is very impressive and useful for robotic manipulation tasks. It can represent objects with rich information. Objects are consistently represented in different viewpoints, and similar object has similar representations. Inspired by this work, our work extends to represent cluttered object scenes, and has sim-to-real consistent representations ability, proposing another approach for sim-to-real transfer methods based on dense visual descriptors. To generate data for training the descriptors, we use the GraspNet dataset, which provides 3D object models and cluttered object scenes. Each scene is captured in different viewpoints with 6D object pose annotations and related camera parameters. To generate the matching points, we proposed object-to-object matching method. We use object pose and camera parameters to project 3D models to the 2D images. We then label the 2D points that are projected from the same 3D points as match points. Similarly, in the simulation, we generate a scene with recording object poses and camera parameters. And then, by using object-to-object matching, we can generate the matching point between simulated and real images. Object-to-object matching method enable many features in our work. We can generate the correspondence between different scenes, different domains. We can also do one-point to multiple-point matching, or texture randomization in the simulated data. We then use pixel-wise correspondence loss to train our descriptor with different type of matching. Our SRDONs is better to represent objects in cluttered scenes and consistent to represent objects in both sim and real data. For example, the banana in both sim and real is consistently represented as light blue in the representation space. We reduce the descriptor dimension to 2 dimensions. We then visualize the random pixel descriptor from both sim and real images. In specific domain, in both sim and real, the descriptor of each object are clearly distinguishable. In different domain, the descriptor of the same object in sim and real are resigned in a similar region, which shows the consistent representation between sim and real data. Here is the demonstration. We use the descriptor to find the matching point between two given images. The heat map indicates how the points in the target image match to the query point in the source image. The hotter color indicates better matching. Our method can also find the matching point under texture randomization conditions. This shows the generalization ability, where similar objects are represented similarly in the representation space. This is another example of finding a matching point from a query point in the source image to multiple target images in different domains. Correctly finding match point shows that the objects are consistently represented. Our SRDONs can also work with unseen objects. These objects are not in the training data. This shows the generalization ability of our method, which is very useful for robotic learning tasks. With sim-to-real consistent representation, we can use the descriptor as the building block in the robot learning tasks. The task is trained entirely in the simulation and then directly transferred to the real world. Grasping object task. The agent is asked to predict the grasping pose of the object. The policy is trained with supervised learning method in the simulation and then test in the real environment. We use SRDONs in more complex tasks, picking cluttered objects. The task is trained with reinforcement learning in the simulation, and then directly transferred to the real world.